Alright guys, so today we're going to be talking about the addition property of equality and the subtraction property of equality. The next section will actually be on multiplication and division, but for now I'm actually going to start this video off with the addition property of equality. Addition property of equality is pretty simple. We're going to talk about addition, but we're also getting into equations, hence the word equality. So if you add the same number to each side of an equation, the two sides still remain equal. So I've got a cool little example here. And we all know that 6 equals 3 times 2, so that shouldn't be a surprise to any of us. But if I do add 5 to both sides of this equation right here, we can see that actually the equation stays equal. 6 plus 5 is 11. We got 3 times 2 equals 6, and then 6 plus 5 equals 11. The rule for the addition property of equality is just that if A equals B, if I add C to both sides of the equation, it's still equal. Still equal. That's the addition property of equality. You might be wondering, where is this going to become useful at? Well, let's see an example here. It's going to come in and help us when we need to solve equations for a variable. Remember, a variable just represents some value. So look at this example here. It says, for what value of m is the equation true? It gives you a little hint, solve for m. So whenever we're solving for a variable, we need to isolate it. That means to get it alone. In this case, we need something to say m equals something. And look at this example. We got m minus 2 equals 3. Well, what value of m would make this statement true? You might already thought one up in your head. And you might be saying 5, and you would be absolutely right because this one's pretty easy. 5 minus 2 is 3. But what if this is a hard problem? Then it might be a little harder for some of us. Let's see here. What if I use this addition property of equality? I have an equal sign. So maybe there's a way to get rid of this minus 2 so that we can get m isolated. And actually, there is a way using the addition property. We're going to do the inverse of minus. And what I mean by inverse is opposite. So what is the opposite of minus 2? The opposite of minus 2 is plus 2. So what we're going to do is, remember, we have to add. If we're going to add to one side, we have to add to both sides of an equation. Okay? Go back to this property here. The addition property of equality is if you add the same number to each side of the equation. Otherwise, the equation is not balanced. So if we add 2 to both sides, we're left with m minus 2 plus 2, because we are adding plus 2 both sides. M minus 2 plus 2. Combine our like terms, in this case our constants. Those actually add up to 0, sorry. And I'm left with m plus 0 equals 5, which means m equals 5. Keep on having this thing pop up. So m equals 5. And we can always check that out, plugging that into our equation. If we substitute into m minus 2 equals 3, if m does equal 5, we can replace m with 5. You can see that's true. 5 minus 2 is 3. Let's look at another example. M minus 2 equals a negative 10. You might actually want to try pausing the video and see if you can do this yourself. But let's continue for now. Um, I'm going to put what I call a lollipop here. Looks like a lollipop, got the sucker and the stick. And what this is going to help me do is it's going to remind me if I do it to one side of the equation, if I do something to one side of the equation, I have to do it to the other to keep it balanced. Think back to the balance video that we watched earlier. So I have m minus 2 equals negative 10. So this one's not as easy to do in our heads. If you can do it, great. So what is it that I have to do to both sides of the equation so that I can get m all by itself and just m equals? Well, we have to do the opposite of minus 2. If we want to get rid of minus 2, we have to do the opposite of minus 2, which is to plus 2. And again, remember the lollipop is here to show me that if I do something to one side of the equation, I have to do it to the other. So add 2 to both sides. It's going to leave me with m minus 2 plus 2 equals negative 10 plus 2, and negative 2 plus 2 is going to be 0. That's just combining like terms like we talked about last chapter. Equals negative 10 plus 2 is negative 8. And m plus 0 probably goes without saying. M plus 0 is just m equals a negative 8. And we can always put that into our original equation. M minus 2 equals a negative 10. M is negative 8, though. This is what we call substitution. Negative 8 minus 2 equals a negative 10. Is that true? Yes, because I'm taking away 8 and I'm taking away 2. So I'm taking away 10 total. So it does work out. So this equation, m equals negative 8. Here's another example. I've got 2 more here. Go ahead and pause the video and see if you can do this one now. So let's begin here. Always start, because I'm trying to get b alone. That means I have to get rid of minus 6. The way you get rid of minus 6 is to add 6 to both sides. So b minus 6 here. Remember, I'm adding 6 to both sides. Add 6 to both sides, making sure I'm doing that. Recognizing now I can combine like terms. In this case, my only like terms are my constants. Negative 6 plus 6 is 0. And on my right-hand side of my equation is 2 plus 6, which is 8. And b plus 0 is just b, and b equals 8. This one's actually easier to see to substitute in. But b minus 6 equals 2, where b equals 8 minus 6 equals 2. And we can see that that's true. So b equals 8 for this solution. Let's do one more example for the addition property of equalities here. I'm just going to add some decimals, and this works with fractions, decimals, you name it, as long as you're doing the inverse or the opposite operation. So I see x minus 2.5 equals 3.5. I'm going to have to do something to both sides of the equation, so I'm going to get my lollipop involved. I have to undo minus 2.5, and the way I do that is with the addition property of equality. The opposite of minus is plus. So remember to do it to both sides. And that's only going to leave me here. We got x minus 2.5 plus 2.5, because I did that to both sides of the equation, equals 3.5 plus, see here, plus 2.5. Combining like terms, you got to simplify both sides here. We see that negative 2.5 and positive 2.5 will combine to make 0. But I still have x. So x plus 0. You guys probably already know what that is. 3.5 plus 2.5 gives me 6. Check that out in your calculator if you need to. X plus 0 is just x. So I have x equals 6. And you can substitute back in to check that out if you'd like to, and correct me if I'm wrong in class tomorrow. So that's addition property of equality. Subtraction property of equality is just what it sounds like. Instead of adding to both sides of the equation, we're going to subtract from both sides of the equation to make it equal still. So for what value of t in this equation makes this equation true? T plus 14 equals 3. Well, let's take a look. Start with my lollipop. I'm going to make sure you know I'm dealing with an equal sign. But notice this time that I have a plus 14 to get rid of, so that I have t alone. Remember, that's my goal, to isolate t. T is not alone here. It has a plus 14, so I have to get rid of that plus 14 somehow. To do that, I'm going to do the opposite of plus 14. The opposite of plus 14 is minus 14. But again, if I'm subtracting off of one side, I have to subtract off the other. This leaves t plus 14, minus 14 on the left-hand side, and 3 minus 14 on the right-hand side. Making sure to watch our signs, we end up with combining like terms. Our constants, plus 14 minus 14 is 0 to give us t plus 0 on our left-hand side, equals 3 minus 14, which is negative 11. And of course, we know that t plus 0 is just t, and that equals a negative 11. Okay, so that's the subtraction property of equality. Subtracting off both sides of the equation does keep it equal. So what about this one? Give this one a shot. Pause the video and give that one a shot. All right, let's try it. I have an equal sign here. I know that m is not alone yet. It's not isolated, but I need it to be to solve for m. So I need to get rid of plus 2. How do you get rid of plus 2? Well, you get rid of plus 2 by subtracting 2, the opposite. Subtract 2 off both sides. So what that's going to leave me with is m plus 2 minus 2 on the left-hand side equals negative 10 minus 2. Well, I see some like terms happening here. My constants are alike, and that's going to be 2 minus 2, which is just 0 again. Go figure, right? Which equals negative 10 minus 2, which I guess I could just write that out. Negative 2 minus 10 is negative 12, because we're taking away 10, taking away 2, for a total of taking away 12. M plus 0 is just m, so m equals negative 12. And of course, you can always substitute this negative 12 into m to check your answer, and you should, which we will be doing in class tomorrow and practicing that. Here's the next practice problem. Go ahead and try that one out. Pause the video, give it a shot. Give it a shot in your notebooks. Alrighty, same steps here, guys. On a lollipop, make sure that I'm doing the same thing to both sides of the equation so that I can isolate b. In other words, b is alone, right? That's kind of my goal here. The only way to get b alone is to get rid of plus 6. The way we get rid of plus 6 is to minus 6 off both sides. It's going to leave me with, on the left-hand side, b plus 6, what I originally had, minus 6 equals 2 minus 6. Well, 6 minus 6 is pretty simple. That's going to give me b plus 0 here equals 2 minus 6 is actually a negative 4, which means b equals negative 4. And if you actually plug this in to check that out, substitute negative 4 in for b, watch what happens. B plus 6 equals 2, but if b equals a negative 4, negative 4 plus 6, is that equal to 2? Yes, it is. So my solution is correct. Another example with a decimal. I've got 2 more examples and the video's over, guys. Same thing here. Go ahead and give it a shot, actually, before we begin. All right. Looks like I'm going to be lollipopping an equation again. My goodness. I still have to get rid of plus 2.5 to get x alone. And the way we do that is by subtracting, doing the opposite of plus, which is minus 2.5. And if I do it to one side of the equation, the lollipop is here to remind me, do that to the other side of the equation as well. If you haven't been able to tell yet, I'm left with x because I'm not touching the x. There's no other terms to combine there. You might be able to tell that these just always happen to cancel each other out. This is going to be x plus 0, and we're always just left with x. So I'm going to stop writing that. It's going to be x plus 0, yes. So an x plus 0 is just x. I'm going to leave just x there. What is 3.5 minus 2.5? Well, that's going to be 1. So x equals 1. And if you substitute x equals 1 into the equation, x plus 2.5 equals 3.5, you get 1 plus 2.5 equals 3.5, and use a calculator, and you can probably just use your heads here. That does work as a solution. So x equals 1 is my answer. One more example here. I have r plus 1.5 equals 2.6. Just some more decimal work here. I'm going to lollipop my equal sign because I have to do something to both sides of my equation. Can you guess what that is? Well, hopefully you got it right. I have to undo plus 1.5. That means I'm going to be subtracting 1.5. Remember, inverse operations are opposite operations. Also, my subtraction property of equality says I have to subtract off both sides of the equation. And just like the last problem, we know that these two are going to cancel out and just make me have a 0. Give me r plus 0, which is just r. And then 2.6 minus 1.5. Uh, you can probably do that one in your head as well. It's going to leave me with a 1.1. So let's see if that actually works. R equals 1.1. Substitute that into my equation. R plus 1.5 equals 2.6. And we're substituting in 1.1 for R. Well, let's see here. 1.1 plus 1.5, 6, and 2, 2.6. Look at that. It worked out. So my solution is R equals 1.1. Don't forget to add your comments to the discussion section, just at the bottom of the Canvas page there. You just need to click on the reply button and answer the three or four questions that are given to you. All right. Bring any questions you have to class tomorrow and ask the questions on Canvas too. That way I can give it a look before they even come to class, and I'll even pick my favorite question and answer that. See you guys tomorrow.